All right, so I want to drill into the security real quick. So the idea is this. Because we're now in the software world, we don't need to worry about hardware constructs. We don't need to worry about, CLI-related stuff and commands and access and all the boring stuff that is don't necessarily have secure data centers. Let's just talk logic. If we're just drawing a policy on the board, on the whiteboard, what would it look like? So the first thing we have to do is we have to group our endpoints together. And hey, let's call them endpoint groups. So that works, EPGs. And so I'm going to take my users and put them into one endpoint group. And let's say a standard 3-tier app, right? So a lot of applications, they'll have a web VM, they'll have an application VM, and they'll have a database, whether it's a VM or a physical, so like SQL Server or something like that. So let's just get these up there. Say, okay, now my users, and I can modify these however I want, by VLAN, by address, by machine name, whatever it is. Put them into a user endpoint group. Put my web virtual machines here, put my app virtual machines here, put my database ones there. And this is a whitelist model. We haven't touched the configuration, or we haven't touched CLI, we haven't done anything, but none of these guys can talk to each other inside my own data center with Cisco ACI. So what do? Well, I got to draw some connecting points, right? I got to say, okay, well, my users have to be able to talk to the web tier, web to the app, and app to database. And well, we don't just want them to have full access, so let's actually do some access controls. We're going to do port 443. Whatever port your application uses, SQL's 1433. We're going to give them specific access to one another. And this all happens at the switch layer. We don't need a firewall to do this anymore. And firewalls in the data center are not cheap. So now all of a sudden we can fit budgets better. How about that? We're actually providing more value and fitting budgets better. That never happens. And guess what? From a policy perspective, it goes beyond security. SDN, ACI, right? We're interested in policy in general. That controller, I didn't tell you what the acronym because we're so sick of alphabet soup sometimes, but APIC is Application Policy Infrastructure Controller. All it is saying, you know what, you create the policy and I'll manifest it for you at the switching layer. So we're just creating a policy here and it's going to do it. And that's what we want in an SDN environment. So now I can say, let's think about QoS. What if I wanted my users in my web tier to have 100 megabits per second guarantee and web to app maybe a gig and 10 gig between application and database, whatever your policy is. I mean, this is like a whiteboard session. If you and I got together and we were to deploy this into an existing infrastructure that's not software defined, I mean, this doesn't take us too long to whiteboard, did it? How about deploying it? Everyone think about how many hours it's going to take to deploy it? And then maybe after hundreds of hours of deployment, we get together and say, all right, we're having our pizza party, and you get the phone call that says, hey, we just bought a new application. Make the new application work with this. And we're all just, okay, party's canceled. We got another couple hundred hours in. New web server shows up, throw it into the same endpoint group. New database, endpoint group. Or worst case scenario, I got to add another endpoint group. Okay, here's another endpoint group. It has to talk to here and this tier, and done. It simplifies our lives and gives us access to security in a way that we didn't have access to it before. One other cool thing from a software-defined perspective would be service insertion. So Cisco has something called layer 4 through layer 7 service. Manifests itself usually in the form of a load balancer or a firewall, right? So if you're going to deploy a load balancer, I mean, it's a nightmare, right? I mean, you're dealing with virtual IP addresses, and you're dealing with VLAN stitching or VRF stitching, and the same thing with firewall. If you're going to do that east-west security I mentioned through a firewall, that's a small nightmare, right? I have to VLAN hop to do that. So let's just get rid of all that. Let's just say, okay, you know what? That web server is going to talk to that application server, but I want to go through a load balancer. I don't want to reconfigure my web server. I don't want to reconfigure my app server. So I'll just create the load balancer in the ACI GUI and tell it, hey, when the web server sends something to the application endpoint group, funnel it through the load balancer. That load balancer can be physical. It can be virtual. The firewall can be physical. It can be virtual. That firewall doesn't have to be Cisco branded. Huh? Anyone? This is all built because it's software-defined networking. It's built on open source, right? Cisco open sourced all of the way they're doing this. And so I mean, I saw a article recently. Anybody know what OpenFlow is? Anybody heard that word? It's kind of what software-defined networking was supposed to be. And I saw an article recently from not even a Cisco website, from a third-party website that said, is OpenFlow dead? And one of the reasons why OpenFlow is dying is because it was built as a lowest common denominator. So whatever switch you bought, whether it was a white box or just some other low-end switch, we wanted it to be able to run OpenFlow. So they made it really low-end. Well, Cisco came out with a very rich set of features called OpFlex, published it, and a lot of the vendors are jumping on board with it. So we've got Cisco competitors that are deploying OpFlex nodes that you can put into your environment, that you might already have in your environment, that you can incorporate into this model, which is really the new way of doing our market. So it's good. It's the new economy.